Hello, today we're going to talk about topic 5, section 8. This is area under a region. So, first of all, we need to understand the trapezoidal rule. Okay, we know trapezoids and hopefully remember the formula, right? The average of the bases times the height. Okay, why is that important? Well, what if I have this fancy equation, right? Like this. So here, and I want to find this area. Well, that's not a shape I know, okay? So what we can do is we can connect these lines, right? See how I'm making it, and then make a trapezoid, right? If I did that actually on the line, right? If I could actually draw. Okay, here we have a trapezoid. So here we average the base, so this height is 2.4, right? This height is 2.8. So 2.4 plus 2.8 divide by 2 times the height, which we can just use as 2, right? Think of it a trapezoid on its side. So times 2. Well, that's the area of this trapezoid. All right, well, let's do another one. What about this one? All right, well, this height, okay, so that one base is 2.8. This base is 1.6. Oh yeah, this is fun. Aren't you loving this? Oh, it's wonderful. And then that height, notice that width is different. It's 1.5, difference between, oh my goodness. I said that was 2, and it's not 2. Holy moly, I can't believe I missed that. Silly me. So that is not a 2. That is a 1.8 right there. Yeah, totally. 1.8 times, totally what I wrote there. My bad. And then this distance from 1.8 to 3.5, oh, I should have watched my x values. Okay, that is what? 1.7. Yes, there we go. Okay, well, this is a whole lot of fun, right? We could keep on doing this, right? We get the idea. And yeah. So I don't really feel like doing that anymore because there's a much easier way to find the area under a region. And you're not usually going to be doing it like this, where it's different distances, right? Different heights, right? Because what if I did more trapezoids and I did them really, really skinny, right? I would get a lot better estimate than this one, right? This has got a lot of extra space I'm adding on. So let's do, oh, yeah. See, sometimes you'll see a problem like this. And so you're given the equation, and then it's bounded by these vertical lines, so at -2 and at 3. And you know that's a maximum, and you know that this is a minimum. So you could sit there and find all your points, right? The x value here is -2. The x value here is 3. You just plug those into your equation to get the y. Here you can find your min and max by plugging it into your calculator, getting the actual min or max on your graph, or taking the derivative and setting it equal to 0, right? So you can get those points and then do the same thing, right? Draw out your trapezoids. This is tedious and annoying, in my opinion. So I would rather just do it with a calculator. Okay? And that's what we're going to do. So this is the part in topic 5, section 5 of integration, where it talks about the area under the curve. So let's see if I wanted to find the area under this. And instead of actually making my own rectangles, I'm going to make a whole bunch with my calculator, because my calculator is a whole lot fancier than me. So what I'm going to do, I already showed you where to go. Clear. Okay. So let's see. We want to go to the main screen and then go to Math, and then you scroll down to number 9 or up. It is FNINT, so you want to integrate the function, so number 9. So mine shows up like this. So you want to, I want to delete that, I don't want a 9 there. Okay, so we start with the bottom number, so that's where we're bounding our bounds of our function are. So we're from 1 to 5, so we're going to hit 1 and then write 5, and write again. Then we can enter our equation. So our function is 1 over x, so we can just do 1 divided by x. Scroll over, and then here it says d, then we put x, so d of x. We're defining the variable x. Okay, we're saying that x is not a constant, it's a variable. Okay, if your screen doesn't come up with this, you have to write it in order. So how you write it is you do the equation first, then comma, x, because again you're defining the variable x, so comma, x again, so then, and then the equation, comma, x, comma, 1, comma, 5. Okay, so again you're just putting all those in order, and then you just hit enter. So the area under this curve is about 1.609. Okay? All right. So you want to practice putting these into your calculator. So again, the x, your lower bound, your upper bound, your equation. All right, and then make sure you put d of x because you're defining the variable x. All right, so practice those, get an answer. Let me show you what you should get with your calculator. Okay, notice how I'm writing my answer. I'm writing it as times 10 to the 10. Do not, I saw this on the test, I'm sorry, the quiz with some of my kids. Do not put 9.98 E10. Okay, that is not, that is what your calculator does, and that is not how we write numbers. Okay, make sure you put it in scientific notation. Okay, all right. So, definite integrals. So this is how the book writes it. Okay, so this is the fancy wording. Okay, so this is how you explain it. All right, it represents the area bounded by the equation and the x-axis and the lines x equals a, your lower bound, and x equals b, your upper bound. Okay, the formula booklet will give you this. So it does tell you that the area between a curve and the x-axis is this. So you just got to remember what the integral is. Oh, but we know our calculators, right? All right, so describe the geometrical meaning of this. All right, again, it is the left, from the left by the line x equals 2. That's your lower bound, so that's your left side. The right side, your line x equals 4, so your upper bound. It's from below the x-axis, and it's from above by the graph. I think I worded that kind of weird. I'm better when I show it. So again, from the left, it's bounded by x equals 2. From the right, it's bounded by x equals 4. From the bottom, it's bounded by the x-axis. And from the top, it's bounded by the function, y equals the square root of x. Okay? So that's the geometrical meaning behind that integral. Okay? So again, type this into your calculator, get the answer, make sure you know how to do that. once you do that, you should get this, 1.21, and you're describing the geometric meaning. So what does that mean? It means this. It's the area of the region between the graph of all of this. Okay, so there's another way of saying it. Between the graph of your function and the x-axis over the interval negative 0.5 to 1. Okay, that's one way of writing it. Okay, so here's another way they could do it. They could graphically show you what f of x is. They don't actually give you the equation. So we want to find this. Well, it's bounded by the function and the x-axis, and when x is negative 2 and 3. So go from negative 2 to 3. And then this is when I get real fancy and, oh look, the area of that is just 1. The area of that is just 1. Oh look, another one, another one, another one. Okay, so then we've got triangles here. Okay, or one big triangle. Ooh, that we can do it in one step. I like one step. So this 1/2 base times height, 1/2. Base is 3. Height is 1. So that's 3 halves. Make sense? Okay. Then this is 1, 2, 3, 4, 5 plus 5, or 10 halves. So 13 over 2. Think I did that right? Yep. Okay. So that's the area. I literally just cut them into pieces, found the shapes of each one. Okay. Was that the only way? No. I could have made a huge rectangle. Okay. I could have made 2 triangles. Whatever. Doesn't matter. Okay. Another practical, or not, the others weren't really practical. They were just equations. All right. So a practical step would be this. So here you've got it as velocity. So again, if you want to get into the reasoning why, I'd have to look into it more. It's kind of technical. I like more of the stat stuff, I'll be honest. But here, what you want to do is when the car stops 5 seconds after the start of the movement. So you want to find your integral. Okay, so you want to find this after 5 seconds after the start. So it starts at 0 and 5 seconds after. So from 0 to 5, and you want to find that distance. Okay, the area of all those distances added up. Okay, and again, use your calculator. Okay, that's what I'm going to have you do. So hopefully that's that makes sense. Yeah, I know you won't really have a whole lot of work to show for this, but I do hope you practice it.